We're back and we're talking about similarity in right triangles. We're going to start off with a theorem, which you can prove. We're not proving it. What the theorem says is when you draw in something called the altitude of a right triangle, it creates three similar right triangles. So before I show you where this altitude piece is, let's label what we already know about a right triangle. Hopefully we know that across from the right angle, which would be this side right here, that's called the hypotenuse. The other two sides are called legs. Okay, to draw in the altitude, what you do is you start at the right angle, and I positioned it up top so it like drops down nicely. You start at the right angle and you drop in a piece that's perpendicular to the hypotenuse. So it's going to create another right angle with the hypotenuse. That is called the altitude, and I'm just going to label it X here. Now, what that will do is that will break the hypotenuse into like two different pieces where it intersects. And a lot of times they'll label those pieces. They'll tell you the lengths. So let's just say it's 4 and 16 on this example. Now, that one piece makes three similar right triangles that are all similar by AA. They have right angles and they share angles since they're overlapping. Now, for the sake of this top example, I'm going to redraw the triangles because that's what we've always done with overlapping similar figures so far. We've separated them and redrawn, and I'm going to call the triangles small, medium, large. The small one is here on the left end, and I'm going to rotate all of them so they're in the same direction. So this one, the right angle is here. So I flipped it. That's 4, that's X. The medium one, I'm not going to flip. That one's already positioned kind of how I want. So this leg is X, and the bottom leg is 16. The large triangle is obviously just the whole thing. You don't know either of the legs, but you do know the whole hypotenuse would be these two added together, 20. Okay, from there I could set up a proportion, and I could just use these two to find X, use corresponding sides, so I could do 4 over X equals X over 16. Those ratios should be the same since those sides correspond. To solve this, I would cross multiply. X times X is X squared equals 64. And then I would just square root, and X would be 8. Okay, I don't know about you, but that's tricky, especially because I had to like flip the shapes to tell what sides corresponded. And that's a lot of work. I don't want to redraw 3 different triangles on every example. And that's all we're doing on these problems today, guys. You're going to be given a picture where the altitude's drawn in. There's 3 triangles going on. You just have to find missing pieces. You could always redraw, but that is a lot in my opinion. So I am not going to show you, or like I'm not going to have you do it that way. I think that's too much work. The rest of the front side of these notes, this is all shortcuts to redrawing on every example. Okay, so we're trying to help you out here with minimizing the work. Now, before I get into the shortcuts, I'm going to mention finding the mean, which is just the average, a lot in this lesson. Now, realize that in algebra, when you find the algebraic mean of 2 numbers, and let's just call them A and B, you do that by adding the 2 numbers and then dividing by 2. So like you would do A plus B and divided by 2. That's how you've always found the average so far. That's an algebraic mean. In geometry, the geometric mean, that's something different. So let's call the geometric mean in this example X. So if I'm finding the geometric mean of 2 numbers, and we'll call them A and B again, you don't add them and divide by 2. Here's what you do. So you would take the 2 numbers you're finding the mean of, and we're setting up a proportion so it kind of like flows nicely with what we've been doing so far. But you'd take those 2 numbers and put them on one diagonal. The mean of these 2 numbers, X, is the number that can fill in that other slot on the other diagonal. It can fill in both of those slots and satisfy this proportion. So here's what I mean. If they say, find the geometric mean of 2 and 18, we're not adding and dividing by 2. we're trying to figure out what number, so we'll call it x again, satisfies this proportion. So I would take 2 and 18 and I'd put them on one diagonal. The geometric mean number is the number that I can put on the other diagonal in both slots that will make this true. It's kind of weird, I know. But you just cross multiply, and that's x squared equals 36. And then I'd square root. This guy has 2 answers, people. This guy did not, because -8 doesn't make sense for this side length. But just in a math problem for the sake of math, a negative answer is fine. So the geometric mean would be positive and -6. That number can slide into that slot and make the proportion true. Okay, you're going to see the geometric mean used in these two corollaries. And corollary, if you forget that word, that's just like a side note to a theorem. So it's saying like, hey, here's this crazy theorem. Well, side note, there's a shortcut to all this work. It's kind of what that's saying. So here's the first shortcut. There are 2. The first one deals with that altitude piece. So it's a shortcut to finding the altitude. The altitude of a right triangle is the geometric mean of the 2 pieces on the hypotenuse. That's great. The sentence doesn't mean as much as I think this proportion will help you. So here's what I'm going to put on the board, and I'm going to drill home these next few days. To find the altitude, that number is the geometric mean. So it's that x value here that you can put in both slots on this diagonal. So the altitude, you can fill in here and here. It's the geometric mean of the 2 pieces on the hypotenuse. So your A and your B from this little generic setup, those are the 2 pieces on the hypotenuse. So I'm going to say piece number 1 on the hypotenuse, and then piece number 2 on the hypotenuse. And I know this looks crazy right now, but I promise with enough practice, you'll get it, and this will be super helpful. So watch, I'm going to use this shortcut right here to solve this problem. So I'm avoiding all of this work right here. Once I memorize this shortcut, and you guys will, if you practice, I would see, oh look, I'm trying to find the altitude on this problem. I know that the altitude can slide into that diagonal, and it's x, so you'd put it in both slots. That's the altitude. And on the other diagonal, I would put the 2 pieces on the hypotenuse of this, and you're only really thinking the big triangle. So here's the hypotenuse, the piece I highlighted. The 2 pieces are 4 and 16. Those numbers would slide into the other slots. And as you can tell, that's the same proportion that I ended up writing right there, but I didn't have to do any of that work. Okay, so this is going to save your life. You just don't know it yet. Okay, get good notes in for that right there. So this shortcut helps you find the altitude. You will also be asked on a lot of examples to just find one of the legs on the big triangle. And with the corollaries, guys, you're no longer thinking small, medium, large. Okay, don't even pay attention to that anymore. If you're asked to find one of the legs, like look here at example 2. X and Z are the legs of this triangle. And I'm not even going to write a sentence. I'm just going to show you the shortcut proportion. The leg, whichever leg you're trying to find, that's going to fill in one slot of the diagonal. And what you're going to put on the other diagonal of your proportion, this is weird, but get it in like I write it. On one diagonal, you're going to put the piece on the hypotenuse the leg touches. And do not worry, I'll explain all of this. In the other slot, you're going to put the whole hypotenuse length. Obviously, I'm abbreviating hypotenuse. I hope that makes sense. So here's what I mean. All right, let's draw in the altitude, because that's always going to be there in all these examples. But I'm not finding the altitude on this example. Let's say I want to find one of the legs. They call that x. They're probably going to give you the 2 little pieces on the hypotenuse here. Here's how you would use this shortcut to set this up. So I see, oh look, I'm trying to find one of the legs here. So I'm going to fill x in both places, because that's the leg I'm talking about. And then the numbers that would go, and x is the geometric mean of these two numbers. In one slot, I put the piece on the hypotenuse that the leg touches. So here's the hypotenuse of the triangle, across from the right angle. There's two pieces there. This leg, it's going to touch one of those pieces. If you like draw an arrow, touches 4 in this case. So that's the piece it touches. On the other slot, that's the whole hypotenuse length. So you got to add those two pieces together. So it'd be 9. And then you can cross multiply and solve. Again, this is avoiding redrawing all three triangles. Okay, let me show you a couple examples. I don't know, maybe I'll do all of them. We'll see how long it takes. Otherwise, we'll finish it up together as a group in class. I'm actually going to do example 2 first, just because it's a little bit more basic. So here's the shortcuts, just so I don't have to keep flipping back and forth. So all I want to do is use the appropriate shortcut, either the altitude one or the leg one. Notice it says leave your answers in simplest radical form when that's necessary. So if that comes up, I'll show you what that means. But all I'm going to do on this example, there's a lot going on. Notice what is what here. So we're really focusing on the main triangle. The piece in the middle is always the altitude. Okay, that's easy to pick out. There's the right angle. It's usually going to be up top. Across from it, this is the hypotenuse. The other two pieces are legs. Okay, so it's probably smart to like label that first. Ooh, that's hard to read for you. Leg, leg, hypotenuse. So pick out what's what, because that's going to help you determine which shortcut to use. So I want to find x first. I see that x is one of the legs. Okay, so my focus is going to shift to corollary number 2. So let's set up for x here. So x is a leg, so I'm going to put x on one diagonal, and you put it in both slots. Don't pay attention to z yet, just focus on x. So that number x is going to go in both of those places. And then up here in the top left corner, I put the piece on the hypotenuse that x touches. What do you know? This is the exact same example. That's boring. So it touches 4, and down here I put the whole hypotenuse length. So I'm going to add 4 plus 5, 9. Good thing I didn't solve it on the back, because this would be boring. More boring than it is. Let's see, that would be x squared equals 36. Square root, x is 6. Negative numbers don't make sense here because it's a leg of the triangle. Okay, for y is the altitude. So when I set this up, I'm going to look at this shortcut. Y is the altitude, so I do y in the altitude slot. And then in the other slots, I put the two pieces on the hypotenuse. So this is my hypotenuse again. 4 and 5 are the two pieces. Okay, so cross multiply and divide. I'm assuming like once it's set up, it's not that bad. Excuse me. Now, then you just square root. Here's where this simplest radical thing comes into play. So radical 20, I'm kind of running out of room. No, I can fit it in here. This is a decimal, it's not a perfect square, so you want to do a factor tree. That's what that means. This is a heavy lesson here, people. There's a lot going on. So there's a pair of 2's, 2 comes out, 5 stays under. 2 radical 5. For z is a leg. So I'm using corollary number 2. Put z in the leg slot. Okay, piece it touches. So z touches 5 on the hypotenuse, which is the opposite of what x touched. But the whole hypotenuse length, that hasn't changed. That's still 5 plus 4, which is 9. Okay, then I cross multiply, so I have z squared equals 45. Okay, here's another factor tree example. 45 is not a perfect square, so maybe like 9 and 5, 3 and 3. There's a pair of 3's, so 3 comes out, 5 stays under. I know you're probably like just panicking. This is like so mathy, it's crazy. But we will spend 2 days on this if that makes you feel any better. I'm going to end with example 1, and we'll hit example 3 later. Don't stress about that. here's what I would do on example 1. And the reason I didn't do this one first, I mean, you could. I think most of us would. Here's what I feel like a lot of people would do. They would see maybe, oh, okay, leg altitude. Well, I'm given the altitude, so let's not do that one. I'm trying to find a leg Y. And you either focus on altitude or leg. Yeah, X is a piece on the hypotenuse, but I gotta focus on altitude or leg. So I think a lot of people would ignore the altitude since you have it, and they'd say, all right, leg. So let's find Y. Y is the leg, so I'd put it here and here. And then they would say, ooh, and let me label. So on the big triangle, if I'm thinking the whole thing, here's the right angle. Across from it, this is the hypotenuse. So then the other two sides are the legs. Piece in the middle, always the altitude. Okay, so I think people would say, all right, the piece on the hypotenuse that Y touches is X. So that would go in the upper left corner. And then the whole hypotenuse, but I would stop right there. If you make a proportion and you're using X and Y, you're never going to be able to solve this. Okay, so that's not going to work. That didn't happen on this one, but it happened here. Sometimes you have to find one variable first before you can find the other. So I would shift gears and say, all right, this leg shortcut's not going to work for me here. Even though I don't need to find the altitude, I have to use it. So let's shift and look at the altitude shortcut. The altitude is 6, so let me slot that in the altitude place. And then the two pieces on the hypotenuse here are X and 2. I just set up a proportion only using one variable. Yeah, it's okay, it wasn't like X and X on one diagonal. As long as I'm using one variable, I can solve this. And this is going to be way easier than the other examples. Just divide by 2, and X would be 18. Okay, I need that information to find Y. So now let's reset up Y. Y is the leg, like we said. So it would go Y and Y like we had it before. But now I know the piece it touches on the hypotenuse is 18. And then the bottom right-hand corner, that's the whole hypotenuse, which would be this whole length here, which is 20. Okay, so this is going to be a little bit easier now. So it would be Y squared. Cool. And then I would have 360, which is not a perfect square. So I'm going to have to factor tree this thing down. And if you're not sure if it's a perfect square, just double check. Like obviously if it's a decimal like that, that's not a perfect square. So maybe I'd do like 36 and 10. 5 and 2, 6 and 6, 3 and 2. Gross. All right, I see a 3 comes out and a 2 comes out. And then a 5 and a 2 stay under. Things that come out or stay under stay under together get multiplied, so it'd be 6 radical 10. All right, we're going to keep it basic with tomorrow. I'll probably show you how to do this third example, and then we'll start slow with this stuff, and we'll carry it over into 2 days.